everyone. My name is Javik Gandhi and I am pursuing Masters in Construction Engineering and Management at SAP University. As a part of our studio, Construction Execution Monitoring and Control, we have chosen a live infrastructure project, Sports Complex. This studio focuses on the various dynamics and aspects to the construction, centered on execution phase of the project lifecycle. Now starting with the project brief. So our project is located in Ahmedabad, Gujarat. Now the objective of our project is to provide Olympic level sports facilities, promoting physical fitness and health, developing athletic skills and abilities, fostering a sense of community, and supporting local sports teams. So our project duration is 30 months. The plot area is 82,507 square meter. The project cost is around 590 crore. The type of the contract is item rate contract. Now we have covered some important topics like pre-construction activities, site layout and critics, planning and scheduling, risk management, and the risk management is done in Primavera Risk Analyzer, material management, quality management, lean construction, and contract administration. We have prepared a 3D model in Revit to show the progress of project in which we have covered some major blocks like block A, B, C, and D. Block B and D have one basement, and block A and C have no basements. Now coming to the concrete planning. So block B is selected for the concrete planning, in which first floor roof slab is shown below for the pore bifurcation. We have divided into total 5 pores, pore 1 to 5. The total area of first floor roof slab is 4,727 square meter, and we have considered the slab cycle is of 60 days. Then we have calculated the floor-wise concrete consumption, in which we can see the total area of the block B is 26,823 square meter for the concreting work, and the required quantity of concrete is around 6,974 cubic meter. Then we have calculated the coefficient of concrete, which is useful to know how much volume of the concrete will be utilized in 1 square meter. So the current coefficient of concrete on site is 0.25 meter cube per meter square, which is not matching the requirement. So we have proposed the new coefficient of concrete, which is 0.26 meter cube per meter square. After that, we have calculated the month-wise concrete consumption. So this graph shows the peak demand for the concrete from November 22 to November 23, and the peak demand for the concrete is in January, which is 986 cubic meter, and then it is in April, which is 952 cubic meter. The calculation for the productivity of concrete work is done for pour one of first floor roof slab. So the concrete required in pour one is 240.79 meter cube. The numbers of labors is around 14, and the total time required is 12 hours. So productivity is calculated by this equation, which is total volume of concrete divided by total time into total numbers of labors. The productivity for this work is carried out 1.43 meter cube per man hour. The location of the batching plant and part of the transit mixture to the block P is shown in this 2D layout. The capacity of the batching plant is 70 cubic meter per hour, but the actual capacity is 56 cubic meter per hour, and the efficiency of the batching plant is taken as 80%. Now, time for 1 cubic meter is 2 minutes, and time for 6 cubic meter to get filled in transit mixer is around 12 minutes. So the number of transit mixer can be filled is around 5 numbers in 1 hour. So the total number of transit mixers available on site is 8. The capacity of the transit mixer is taken as 6 cubic meter. The number of transit mixers used for pour 1 in the first floor roof slab is around 41. So for concreting of pour 1, around 41 number of transit mixer is required. The required time to get filled of 41 transit mixer is around 8.2 hours. Coming to the foreman delay survey. The foreman delay survey is a lean tool which helps in measuring the worker's performance in an activity and increasing the productivity. The process we have adopted in this activity is shown in flowchart. Initially, we have chosen the scope of the work, then observed various activity involved in that work, and analyzed all the workers involved in that activity to know about the delays by each workers involved in that activity, and add suggestions to eliminate the delay time to increase the productivity. We have chosen brickwork activity in block B, and the duration of that activity is around 336 minutes. The number of workers were 2 mason and 2 helpers. We have identified the total 8 reasons for the delays, like tool mobilization, line layout and design, receiving instructions or discussion between them, housekeeping, late arrival, personal break, waiting for material, and idle time. So major delay was occurred due to waiting for the material and due to idle resting. And the other delays like using of mobile and discussion with the other workers was happened. So this graph shows the working and non-working time of the workers. In this graph, the blue column shows the total duration of the work, red column shows the non-working time, and the green column shows the working time. So the highest working time is 259 minutes, which was of helper 1, and the highest non-working time is 143 minutes, which was of helper 2. So we developed the spaghetti diagram to show the current state of the different species, such as working area, cement storage area, brick storage area, sand storage area, and so on. We observed that whenever workers traveled to these spaces, it took quite a lot times. To avoid that, we proposed new spaces and brought these places nearer to the working area to reduce the travel time. The current path is shown as the full line and the proposed path is shown as the dotted line. Now after proposing a new locations, the travel distance is reduced by 233 meters. In the delay analysis of all the workers, Mason 1 and Helper 2 did the highest delay, and the main reason for a delay is due to waiting for the material and personal break. Now these two causes of the delay is 47% of the total delay. Now we have categorized this delay into two categories. So some delays are supportive delay and some delays are recoverable delay. So in the total delay, 75% of the delay is recoverable and 25% of the delay is supportive. We have done the cost analysis for each delay, in which wages per hour of the workers are calculated. Then total cost of each workers is calculated as per their delay time. The total cost lost due to delay of each worker is 543 rupees. So the inference of this formal delay survey, so that after analyzing the delay of the works, it has been found that maximum delay is caused by the waiting for the material. And the suggestion to reduce this delay is helper 2 should also help helper 1 in bringing material instead of just standing idle. Now coming to the tools of quality. So tools of quality is a part of quality management. Tools of quality are used to analyze problems related to quality in statistical way. The tools which we have used is control chart, Ishikawa diagram, and histogram. Benefits of the quality control are it improves quality, decrease variability, reduce cost, and reduce waste. Now the first tool is control chart. So control chart are used to determine whether the processes are operating within the permissible limit or not. For the analysis, we have selected the 28 days compressive strength for M35 grade concrete cubes. X bar chart shows the mean of all the samples. The upper control limit and lower control limit is calculated from the X bar graph theory. All the samples results should be within this upper control limit and lower control limit. And as per the IS 456, the results should be between the plus or minus 50% of the FCK. As we can see, all the results are between the upper control limit and lower control limit as well as within the IS code criteria. But only one reading is above the upper control limit, which is also considered optimum because it is less than the IS code criteria. Now coming to the I bar chart. So R bar chart shows the range, and as we can see, all the samples are between the upper control limit and lower control limit. So the NC was observed on the site, which was a wrong methodology in backfilling work. So Ishikawa diagram is used to know the various causes of this non-conformity. So backfilling work is one of the most important work which was not done as per the contract specification. So causes were understood and divided into 5 M's. First is machine, manpower, method, material, and management. So the major causes is highlighted with the red font. In machine, improper or insufficient use of equipment for backfilling work at site. In manpower, improper supervision by site supervisor or engineer. In method, non non following up the method of treatment at the site. In material, improper inspection of the soil being dumped. In management, lack of the coordination between the staff and subcontractor. Now, the third tool is histogram. So, histogram is used to summarize continuous data that are measured in interval scale. For the analysis, impact value test of 20 aggregate is used. So, a total 30 numbers of samples are taken for the analysis, and all the samples falls between the range of 8.30 to 11.30%. As per the IS code 383 criteria, the impact value of 20 aggregate must be less than the 45%. So as you can see, all the samples fulfill the criteria of IS code and falls under the prescribed limit. Now, coming to the cost of quality. So cost of quality includes quality management cost and deviation cost. Quality management cost includes prevention cost and appraisal cost. So in prevention cost include cost of internal quality audits, cost of equipment, QC lab cost, preparation of quality assurance plans, and training of the quality personnel. Where appraisal cost includes calibration of the equipment, external test cost, and the appointment of the quality personnel. In appraisal cost, the cost of appointment of the quality personnel has the highest cost, whereas in prevention cost, the cost of equipment has the highest cost. The cost of external test is also considered because the on-site laboratory is equipped with limited resources, so necessitating the utilization of external testing facilities for certain tests. So for the non-conformity, the two non-conformity was observed on the site. And for non-conformity, the process of termination of non-conformity is given on the site. The first non-conformity is wrong methodology in the backfilling work, and this problem was occurred due to improper backfilling. The depth of the area is 2.8 meter and the width is 1.85 meter. It is recommended that the backfilling work should be performed in layers and each layer should be 200 mm and every layer must be compacted for the optimal results. The total cost incurred in this non-conformity is 1,03,952 rupees. Now coming to the non-conformity 2, which is a bulging of concrete, which was done due to improper shuttering work. So the footing size is 5 by 6 by 1 meter and the size of the defective area is 6 by 0.25 by 1 meter. The total cost incurred in this NC is around 29,428 rupees. So the Nitabond chemical is used in this NC to join the old concrete and the fresh concrete. Now the key learnings. So first one is concrete planning. So slab cycle as well as the peak resources requirement for the material and the labors are investigated. The new coefficient of the concrete is proposed. Month-wise concrete requirement is carried out, and the peak requirement of the concrete was now 986 and 952 meter cube. So required numbers of transit mixers for is calculated for particular pour. Now, foreman delay survey. The foreman delay survey exercise was performed for the brickwork activity. This helped us to know the delay causing actions or activities during the process of brickworks, and suggestions were provided discussing how this delay can be minimized. Now, the tools of quality. Tools of quality are implemented in various steps of process in order to define problems. Control chart are used to check the variation in the process. Ishikawa diagram helps in finding out the potential cause of the problems. as well as the histogram helps to check the frequency of the occurrence. Now, cost of quality. The term cost of quality refers to the expense of the quality management as well as the cost of deviation. The cost of non-conformance will be reduced if there is a greater focus on quality management, prevention, and the appraisal cost.